Assalamualaikum and hi everyone. Today, my groupmates and me, we will presenting about periodicity, the physical properties of the elements in period 3. Starting with my part, I'll describing the variation in atomic radius, ionic radius, melting point, and electrical conductivity. Then, Keshika will interpret the variation in melting point and electrical conductivity. After that, Ashikin will explain the variation in the first ionization energy and also explain the strength, high melting point, electrical and shielding properties of ceramics. Atomic radius. What is atomic radius? The atomic radius is the distance between the nucleus and outermost electron of an atom. The atomic radius is measured by taking two atoms of the same element, measuring the distance between their nucleus and then halving this distance. Ionic radius. What is ionic radius? The ionic radius is the distance between the nucleus and the outermost electron of an ion. Metals produce positively charged ions, whereas non-metals produce negatively charged ions. Going across the period from ion natrium to ion silicon, the ions get smaller due to the increasing nuclear charge, attracting the outer electrons in the second principal quantum shell nucleus. Going across ion phosphorus to ion chlorine, the ionic radius decreases as the nuclear charge increases across the period, and less electrons are gained by the atoms. Melting point. The table shows that natrium, magnesium, and aluminium are metallic elements which form positive ions arranged in a giant lattice in which the ions are held together by a sea of delocalized electrons around them. Silicon has the biggest melting point due to its giant molecular structure in which each silicon atom is held to its neighboring silicon atoms by strong covalent bonds. Phosphorus, sulfur, chlorine, and argon are non-metallic elements and exist as simple molecules. The covalent bonds between the molecules are strong. However, between the molecules they are only weak instantaneous dipole-induced dipole force. Electrical conductivity. Going from natrium to aluminum, there is increase in the number of valence electrons that are donated to the sea of delocalized electrons. Silicon, there are no delocalized electrons that can freely move around within the structure, and it is not a good electrical conductor. The lack of delocalized electrons is also why phosphorus and sulfur cannot conduct electricity.
Hi everyone, I am Keshika Anaprapuan Ganesan. I am from K3. Today I am going to describe about the physical properties of elements in period 3, which specifically I am going to talk about melting points and electrical conductivity of elements in period 3. First of all, we are going to see about the melting point of the elements in period 3. The melting point increases from natrium to aluminium because the strength of the metallic bond increases. The melting point of silicon is highest because silicon has a giant covalent structure. A lot of energy is required to overcome the strong covalent bonds. The melting points of phosphorus, sulfur, chlorine, and argon are lower because these have simple molecular structures. Only weak van der Waals forces of attraction exist between them. The attractions and therefore the melting point increase because the nuclei of atoms are getting more positively charged, the sea is getting more negatively charged, the sea is getting progressively nearer to the nuclei, and so more strongly attracted they are. Okay, next, so we are going to see about the electrical conductivity of the elements in period 3. The electrical conductivity of period 3 elements increases from natrium to aluminium because the number of electrons contributed by per atom to the sea of delocalized electrons increases from 1 in natrium, 2 in magnesium, and 3 in aluminium. There are more electrons to conduct electricity. The electrical conductivity of period 3 elements decreases from aluminium onwards. Silicon is a semi-metal, therefore it is a semiconductor. The remaining elements do not conduct electricity because there are no more electrons. As we all know, the elements in period 3, which is natrium to aluminium, is metal. Silicon is considered as semi-metal, and also phosphorus to argon are non-metal. The electrical conductivity is highest in metal, lower in semi-metal, and also most non-metal do not conduct electricity. That's all from me. Thank you so much. And after this, my other group member will describe more about the physical properties of elements in period 3. Thank you.
Hi everyone, now I am going to explain to you about the variation in first ionization energy, and then I will explain about the strength, high melting point and electrical insulating properties of ceramic, focusing on magnesium oxide, aluminum oxide and silicon dioxide. So first of all, what is first ionization energy? Well, it is defined as energy required to remove 1 mole of electron from 1 mole of gaseous atom to produce ion with the charge of positive 1. Okay, now I'm going to explain to you about the trend of first ionization energy when going down the group. So going down the group, the size of atom will increase and the number of shell will also increase. The distance between valence electron and the nucleus will also increase, but the attraction between valence electron and nucleus will become weaker. When the attraction becomes weaker, it is easier to remove the electron, so less energy is required to remove the electron. Thus, the first ionization energy when going down the group is low. And also, as you can see, I also put the acronym outside of the box, so I hope it might be helpful for you to memorize the points. Okay, now let's move on to the trend of first ionization energy when we across the period. So it is actually opposite to the previous one, where the size of atom will decrease, meaning that the number of shell will also decrease. The distance between nucleus and valence electron will decrease, but the attraction between nucleus and valence electron is now stronger. So it is harder to remove the electron and it is required more energy to remove the electron. Thus, the first ionization energy when we cross the period is high. Okay guys, now we are done with the variation in first ionization energy. Now we will look at the strength, high melting point and electrical insulating of ceramic. Okay, first we will look at the strength of magnesium oxide. Magnesium oxide is a hard malleable compound where the atoms of magnesium holding themselves together in a regular lattice structure. So because of that, magnesium oxide cannot be destroyed easily. Okay, then for aluminium oxide, it is a strong compound where in aluminium, the particles are touching each other and there are gaps between them. So when it becomes aluminium oxide, these gaps are filled with oxygen atom. So that's what make it become a stronger compound. But for silicon dioxide, we can say that silicon dioxide is not a malleable compound because when pressure is applied, the strong covalent bonds between the atoms have to be broken down. So only that the atoms can move. Okay, why magnesium oxide and aluminum oxide have high melting points? Okay, this is because there are strong attraction between the ions in each of the oxide. So it requires more heat energy to break the attraction. That's why the melting point of aluminum oxide and magnesium oxide is high. Okay, so what's about silicon dioxide? Silicon dioxide also have high melting point because it is a giant covalent structure. So it requires a lot of energy to break the strong covalent bond throughout the structure. So that's why silicon dioxide also have a high melting point. Okay, last but not least, I will explain about the electrical conductivity. For magnesium oxide and aluminum oxide, they cannot conduct electricity in the solid state because they don't have any freely moving ion. However, they can conduct electricity if undergo electrolysis in a molten state. This is because the movement of the ions toward the electrode and also the discharge of the ions when they reach the electrode. Okay, for silicon dioxide, It does not conduct electricity either as a solid or as a liquid. This is because in silicon dioxide, there is no mobile ion or electron. Okay guys, that's all from me, and I hope you guys learned something from my presentation, and thank you for watching. Bye!